Hi, thank you for joining us. My name is Acha,
I'm Ethan.
I'm Rachel.
I'm Eric.
and we're the team from Olivet working on the golf course renovation. So we'll play a short clip here of the course if you haven't seen it. If you have, this will be a good reminder. Beautiful place right next to the Kankakee River in Aroma Park. It's technically Aroma Park. I guess we all just kind of call it Kankakee since it is Kankakee Elks. But it's almost 100 years old, 104 years. It's beautiful right next to the forest. A lot of trees have come in the recent years, and you can see it's pretty well kept up.
So our sponsor for this project is you, the Kankakee Elks Country Club and Golf Course. We were approached by Joe, and he asked us to help them with some improvements so they can increase their clientele. So our goal is to develop a plan with cost estimates that will ease into decision making. So when the committee comes together and wants to make a choice on what to do, they have this laid out easily for them so they can make their choice and there's no arguments or anything.
So our design objectives for the project, we wanted to split it up into 4 parts. So for the halfway house, we want to design a halfway house that is a scaled down clubhouse experience. For the tree removal, we just want to improve the playing experience. For stormwater, we want to create a stormwater design to reduce the standing water in the northeast section of the golf course, which has the drainage issues. And for the golf cart paths, we want to reduce the wear and tear on the golf course. So to do this, our functional requirements will be to provide a restroom, an area for shelter and vending machines to improve the halfway house that is currently there. For the tree removal, we want to remove some of the trees in the tight areas so the fairways have more space for playing. For the stormwater, we want to design a basin, an outflow structure, and a grading plan to increase the drainage. And for golf cart paths, we want to implement a continuous path with a permeable material.
Our design constraints are pretty simple. Maintain the difficulty of the course while keeping the historic significance from the person that originally designed the golf course. We split up the task by our skills. I got the halfway house, Ethan got the stormwater, Achi got the tree removal and gazebo, and Rachel got cart paths. So as you can see, that's how the bathroom looks like right now. Our goals were to expand the restroom sizes since they're pretty small. Try to include an ADA accessible bathroom, incorporate a shelter to the design of the building, and keep the vending machine area. This is the structure of the bathroom as it is now. This wall splitting the building is as it is, and there's one down the middle for the 2 bathrooms that are in place right now. So we are looking at making the bathrooms ADA compliant, which we were able to make one of them ADA compliant and the other one fell short by just the dimensions. But we are still gonna keep everything ADA compliant in both restrooms. We're putting in ADA compliant toilet, sink, and fixtures. The rear grab bar has to be a minimum of 36 inches. Sidewalk grab bar is minimum of 42 inches. For it to be ADA compliant, it has to be 6 feet 6 inches by 7 feet 6 inches. It has to have a minimum 60-inch radius for a wheelchair to turn, 36-inch wide doors, and 18-inch center to side walls for both sink and toilets. As you can see here, this will be your ADA accessible bathroom, not ADA accessible with ADA accessibility. These are the posts for the truss system we're trying to put in. There's gonna be trusses 2 feet space with 4 trusses hanging from each side as the shelter. And then, can you go to the next slide? As you can see here, this is the exterior with actual topography as it looks right now. This design will be just the design with which we can still make adjustments to it as we go. For example, maybe a sidewalk wrapping around, but we're trying to keep it as budget friendly. So this is what we're going with for now. This is the ADA accessible side, as long as this one, and then this was just the other bathroom. We included a urinal. Since it won't be ADA accessible, we decided to take off the rear grab bar and add a urinal, for more accessibility to the golfers. Yeah.
Okay, so next we'll hit the gazebo. This was really just supposed to be kind of a superfluous extra aspect of our project, because when we're looking at the gazebo, it doesn't look too bad. You can see that there's like a little bit of rot maybe and a little bit of shingles coming off, but it doesn't look awful. But when you do actually step into it and you see how much rise in the supporting beams, you can see it's almost kind of a hazard. So we know that it's about 70 years old, the gazebo itself. So we thought in the long run, it might be better that we just replace the whole thing instead of replacing just individual sections. That way you won't have to deal with the side sway issue when a big wind comes around and you got a gazebo flying all over your golf course. So when we were thinking about how we were going to tackle the renovation, we had a couple things in mind. We had thought about maybe doing something from scratch, designing that, and then just sending it out and having someone build it. But then one of our faculty mentors suggested that we look for gazebo kits from different companies in the area. One such company, Country Lane Gazebos, I was able to reach out to them and I gave them some pictures of what we had and see if they could maybe make something similar. And they gave me this preliminary design. It looks pretty similar to me, and it has the same dimensions. We're gonna keep the base because the foundation was pretty strong. It's a 14-foot diameter. They'll also add benches, but they didn't include that in there when I first contacted them. And it's the same style. It has the pagoda, it has the cupola, it has everything that's on the original. And they gave me an initial quote, which was $4,800, and that's, of course, variable to fluctuate. But it seemed like it would probably be simpler and in the end more cost effective than doing it from scratch. And my second focus was the tree removal. As some of you may know, the course when it was first designed had almost no trees on it. If you see this picture to your left, you can see this is a survey from about 30 years ago. And even in that picture, you can see that there are hardly any trees. This is on hole 8, right at the end of the first 9. And there are hardly any trees back there in 1990, 1992, something like that. But this is a picture from just a few months ago, and you can see, especially where the green is, a lot of trees have choked up that area, making play a lot more difficult. So when going into this, I'm not an avid golfer, so I had to consult some people and see, okay, what kind of things can I take out and still like have the golf course remain the right level of difficulty? Because I know sometimes trees are supposed to be in the way to make the game more interesting. But the general consensus that I got back was that because this course was designed without the trees in mind, the course itself, it has the intrinsic difficulty built into it with its bunkers and its shape and its path. So really anything that seems very, very in the way, such as some of these trees down here, we should try to remove, especially if it's really, really bad. So to see where the worst problems were, we kind of did a little function to see average fairway obstruction. So basically, any trees that were hanging out into the fairway, we saw how far they were hanging versus how wide the actual fairway was. On average, there's about 11% obstruction in the fairway. So it's like about 11% of the width is tree above the fairway. So there are 3 specific spots where it's a lot higher than that. The first one I showed you, that's hole 8. The width of that fairway is 60 feet. And then there's only 24 feet of open air above the fairway in that specific section. So it's about 60% of obstruction. So that would be a great place to remove a couple trees just so you can get in there a little better. I know that's already a difficult hole to shoot anyway. And then the other sections are in hole 6, that's about 44% obstruction. And in hole 15, that's about 56% obstruction. So those three, there's about 9 or 10 trees that could be removed. Almost 3 in each one. You could remove more or less depending on how difficult you do want to end up making the course. So in all, it's an area of 10,500 square feet that would need to be removed, or in this case, stripped is like the word that the Kankakee ordinances use for removing trees or any wildlife. So looking at the Kankakee County ordinances, it says if you're removing anything in excess of 5,000 feet, you have to get a permit. So there's a couple options that you can go forward from here. You could either do everything all in 1 year, and then you would definitely have to get the Class 1 grading permit. Or if you wanted to split it up between fiscal years, so maybe just do 1 hole per year, trying to cut back on the trees, it would actually be a little bit less than 5,000 in each case. That way you wouldn't have to get the permit, and maybe you could bankroll some of the budget into the next fiscal year.
So the next aspect to our design project is the stormwater design. Right here is a flow chart of how you go about designing the stormwater aspect. So the first thing is to delineate the watershed. We did this using ArcGIS. We were able to download a topographic map, and then it allows you to delineate the watershed using the program. The next step was to compute the peak runoff. So we did this using the NRCS method. This will also give you a hydrograph that will give you the peak runoff over a period of time. The next step then is to design the basin. So to do this, you have to assume a volume and an outlet structure, and then run the calculations to see for the next step if the outflow hydrograph is less than the inflow hydrograph. If the outflow hydrograph is less, then you know that your basin is satisfactory, and then you can move on to the final step, which is finishing the engineering drawings. So right now we are somewhere in the midst of step 3, and then next semester we will complete that step in 4 and 5 as well. So right here, we have a picture of the watersheds and the hydraulic path. So the watersheds are the pink line. You can see that they're outlined here. And then the hydraulic path is this blue line. So the water runs from this point following that way. As the line gets darker, the flow gets larger. So you can see we would find that the time of concentration from the furthest point would start down here to this line to where the first basin would be. So our idea is that the water will flow from this watershed into this basin, and then it would be held up by a dam that will be where the cart path goes over. There will be a small pipe that at the event of a 100-year storm, which is a large rain event, the water will raise up to the elevation of that pipe, and then it will flow over the fairway into the next basin, which will be located here. And here will be the same situation. There will also be a dam with the cart path running over it. But the way it will be designed, the water will only reach the elevation of the pipe to flow over the fairway in a large rain event. In this case, we would imagine that the golfers would not be golfing in that rain event, so it's okay if the fairways get a little wet. But for anything less than a 100-year storm, the water will not run over into the fairway, so it will be kept as dry as possible. So here's an example of one of the calculations we've done. So that is our runoff hydrograph from the peak runoff. So you can see we found the peak runoff was right around 31 cubic feet per second. And so with that information, we'll move into computing the volume calculations. But to compute this peak runoff, you get a value from the empirical data. That's just a bunch of tests that have been run to find in certain situations what this number would be. You multiply that by the drainage area, which in our case is, for the first watershed, is right around 0.06 square miles. And then the runoff in inches is right around 1.5 inches. So that gives you the peak runoff of 31 cubic feet per second. But you can see down here, these are the numbers you use to find the runoff hydrograph. And again, this is just from empirical data based on the NRCS method.
Okay, so for the cart paths, like Ethan was saying, in the northeast section of the course, we want to raise up the cart path so that way it's not going to be in the water. So this is a general basic cross section that I created. So here, this is approximately going to be 10 feet by 2 feet going like out basically, and then the height is about 2.5 feet from the ground to the top of the path. So this will fill up with water. This pipe is angled down, so when this fills up, it drains out from the pipe. These measurements are not exact yet because we haven't done all the calculations yet, like Ethan said. But next semester we'll finalize these or change them if we need to. But this is the general, like, what it's gonna look like. So basically, the primary objective of the cart paths is to minimize wear problems and improve aesthetics of the course. So this course does not have a continuous path, as you know. So these white lines are all of the paths that are existing on the course. And then this is what we propose to, where we propose to make the rest of the path. So the pink lines will be, Ethan helped me to draw those, just like, cause he's played the course, several times. So he thought of idea, where we can put the path. And so this is what we're proposing. This is all, it's just a rough sketch, but we're gonna make it better next semester. Some of the materials that I've looked into are gravel, asphalt, concrete, and impermeable paver material, which is all the way on the right. So some of the factors that affect the design and how we can choose the design are traffic intensity, how many people are playing the course every day, and how many golf carts are going to be driving on it. The funding available is a big one. The budget is not huge for this project, so we want to keep it as low as possible. The stormwater runoff is another big one. We don't want standing water on the paths at all. And we also want ease of maintenance and strength to be factors as well. So I created this table with each of these materials. The last two are a permeable material. The difference between these two, they're very similar, but the first one is a little bit thinner and not as deep, so that's why it's cheaper. But this is just a little bit stronger than this one. Gravel, asphalt, obviously those. And then for the lifetime, it can also be a range. These are just kind of estimates of each of these, estimates of prices. It's not definite because I didn't consult any contractors or anything, but I just looked up these prices and then the permeability as well. So using that, I created a decision matrix with each of the types of materials and all of the factors that I talked about. And then, so a score of 5 is very good and 1 is not good, so we want a higher score. And from this you can see that the TrueGrid paver is a score of 25, which is the highest, so we're recommending that material. And all of these numbers is just kind of an engineering judgment, there's no right or wrong answer to all of these, it's just what we think will be the best for the paths based on all of these factors. And then this is an example of a memo and journal that we've been doing throughout the semester and how we have used pictures and things in the journals and a memo to our sponsor just with our updates and questions that we've had for them. And then
So some of the issues we've dealt with this semester is learning new software. I had to completely learn ArcGIS, none of us knew it, so we had to do that from the beginning. Also, we will need to use AutoCAD next semester. Rachel will have to learn that. Eric's been using Revit, but he's had some experience with that, so just learning these new softwares has been a challenge. And then we also all have very busy schedules with sports and work, and so just finding a good time to meet and a good time to work on everything has been another challenge. Thank you.